Hello everyone. Today I will record some notes or narration for the small open economy overlapping generations model. My voice unfortunately is not quite up to scratch, but hopefully you will be able to hear everything. As a way of motivating this, we live in an economy which is an economy that is small and that is open to the world capital flows and trade flows. What does this imply for economic analysis? The main characteristic that we will incorporate in our analysis is the fact that the price of capital, which is the interest rate, is not on the world markets, is not going to be influenced by the demand for this capital by the small economy. So if New Zealand demands more or less capital or supplies more or less capital to the world market, that will not have any influence on the interest rate that is being charged on this world market. How realistic is this? It's quite realistic. There is something called the risk premium, which we are going to ignore, which depends on a country and it also depends on time. But for now, we'll simplify our analysis by ignoring that. Of course, the fact that countries are open to international trade and capital flows is hugely beneficial. It basically allows for specialization, and you know from first, second year economics and from international trade how beneficial specialization can be in terms of allowing country to yield benefits from specialization, so comparative advantage I was going to say. So we are just going to adjust the overlapping generations model into international trade, but it's going to be extremely simple. Basically, what this is going to boil down to is an economy which has an interest rate which is exogenous, rather than an interest rate that is determined by the demand or supply of capital, savings and investment inside of the country. Consequently, since interest rate is a price, one of the prices is going to be exogenous to the country. It's going to be determined on the world markets, and that will help us solve the model more easily, essentially, because we are going to be assuming that one of the determinants in our model, which is typically an equilibrium outcome, instead is going to be not an equilibrium outcome, but it will be a predetermined variable which will be equal to the world interest rate. So what are our assumptions here? Capital is mobile across countries, but the labor is not. And now this is not entirely true, but in terms of the ordering of the assumptions, capital being more mobile than labor, that is certainly the case. So we can make the simplifying assumption here without a major loss of generality. And as I mentioned, the small open economy assumption means that the interest rate on the world market, as well as supply and demand on the world market, cannot be influenced by the small open economy. Consequently, we take these rest of the world, or we'll model the world as a single entity for simplicity, and we will assume that none of the variables, most importantly from our perspective, is going to be the interest rate, but none of the world variables will be influenced by whatever is happening in the small open economy. However, the reverse is not going to be true. All of what is happening in New Zealand will be influenced by what is happening in the world economy. So it's a one-way causality that is going to be happening in our model. So the labor clearing condition will be defined for each particular country, but the capital market market clearing condition will be defined by the global supply and demand for capital in the world, and consequently that's what will determine the world interest rate, which will then trickle down and influence the amount of capital as well as labor and consequently output and consumption and investment in the small open economy. Okay, so this slide basically says that, which I've already mentioned. Now, in an equilibrium, the net foreign asset position, and so the current account, will be defined by saving of the country and the demand for capital in the country. So saving and investment. That's pretty standard, but it'll be a little bit different because of the assumption of exogenous interest rate, world interest rate. Let the time be discrete again. The economy extends over an infinite number of periods. N T identical individuals are born each period, so it'll be generation T, and this population grows at a constant rate, lowercase n, and everyone lives just 2 periods. So this is standard overlapping generations model that we have looked at many times. At any point of time, of course, since these generations overlap, there are 2 in existence, n t number of young people and the old people. How many old people are there? Well, it's n from t minus 1, since the capital N t denotes the number of people that are being born at time t. So n old people in period t were young in period t minus 1. So capital N t minus 1 is the number of old people living in period t. How many of them were there? Well, that's just since growth rate of population is 1 plus n, or well, the net growth rate is just lowercase n, then the ratio of capital NT divided by 1 plus n is the number of people who are old in period t. Standard optimization maximizes, so an individual in this overlapping generations model maximizes a utility. He or she lives in for 2 periods. 1 over 1 plus theta is a discount factor, so theta is the parameter which measures impatience of the individual. We assume that the utility is logarithmic, instantaneous utility is logarithmic, subject to budget constraints, both for period t, which is the first of the 2 budget constraints, and for period t plus 1. Period t, you have a choice to consume or to save, and this sum of the consumption and saving we assume is equal to the income from wages. Of course, it could be less than, but we assume non-satiation. So you are too greedy, you want to consume everything you have or save. You're not going to just destroy income. In the second period, you use the savings. You don't have any income by assumption. Use the savings that you've accumulated to to consume, plus the interest on those savings. So as we had in the first week lecture, consumption in period 1, also consumption when young, is a constant share of the lifetime wealth. In this case, lifetime wealth is just the wage income, and there is no labor leisure decision, so the wage income we assume is full-time wage, and the share of it is 1 plus theta over 2 plus theta. In the second period, consumption is again a share of lifetime income, but this share now depends on the interest rate, and there's the substitution effect in work. Finally, savings is the leftover, essentially, so leftover from consumption in the first period, or so I should say leftover from the income in the first period, which is not consumed, and that's just 1 over 2 plus theta times WT. Now, because of the assumption of small open economy, normally we would have to pair these first order condition, well, these consumer demands for period 1 and period 2 consumption with the supply of savings, as well as demand for capital, with the demand for capital and possibly demand for labor conditions, so firm maximization, in order to solve exactly the amounts for the relative price of wage of labor, which is the wage, and relative absolute price of labor, which is wage, and absolute price of capital, which is the interest rate. However, here we are assuming that because the capital market is assumed to be international and mobile, and we are a small open economy, the interest rate is going to be determined by the world market, not by the domestic considerations. We also assume that labor market is isolated, so there is no free flow of labor. Consequently, the wages will still be determined by the domestic conditions. All right, so the firm side of the optimization is, as usual, output follows a certain production function, which we will just make it more general, or satisfies the usual conditions. So it's increasing and concave with and it satisfies the in-other conditions. So you will never want to produce at zero capital, and you will never and the marginal product of capital at k going to infinity equals 0. For now, we just assume there is no capital depreciation for simplicity. First order conditions are the usual conditions, which are the marginal cost of capital equals marginal benefit or marginal product of capital, and similarly for labor, so marginal cost of labor, which is the wage, real wage, equals the marginal product of labor, denoted by capital F with the subscript of L, and marginal product of capital is denoted by capital F with the subscript of K. In per worker terms, again from the first week, we can express it as follows. So the last two equations on this slide are the same as the first two, what I expressed in per capita or per worker terms. And as we have assumed that the markets are perfectly competitive, we find that these conditions are basically saying that each factor is paid its marginal return. So marginal, so the wage is equal to the marginal product of labor, and the interest rate, which is the remuneration to capital owners, is equal to marginal product of capital. The labor market condition here is extremely simple. So L equals N at every period of time, and that's simply by assumption that only the young people or the young generation works. The capital market equilibrium condition, now we allow for country to borrow and save amounts that differ from the demand. So supply and demand of funds of capital stock need not equal, as it was the case for a closed economy, and consequently there may be a difference between the two, and the difference between the supply of capital, which is S lowercase s savings rate, times the number of workers, minus the demand for capital, which is just the demand by the representative firm, capital K T plus 1, is equal to the net foreign assets. So if you supply more than you demand, your net foreign assets are positive, greater than 0. If you demand less, if you supply less than what you demand, that these net foreign assets are less than 0. Consequently, essentially, if a supply of capital is bigger than demand, that I'm going to be accumulating, I'm going to be sending this capital overseas, abroad, and I'm going to be accumulating net foreign assets in exchange for that capital stock, and vice versa. So if I'm going to be borrowing more, if my demand for capital is bigger than the supply, which is New Zealand's case, then I'm going to be decumulating the net foreign assets in my country. Right, so these conditions, well, the last one is the difference between a closed model and an open economy model, small open economy model. So we need not assume that capital demand equals capital supply, and investment demand equals investment supply, and therefore savings equals investment at every period of time. These two in conjunction, or the difference between these two, defines the net foreign assets, which may be positive or negative. Because these do not need to equal, we have a sort of an issue. We can't pin down the domestic interest rate without making any other assumptions. So the assumption that we are going to make is that the interest rate on this market for capital is going to be a foreign interest rate. So it's going to be an international interest rate. So it's going to be exogenous, in particular, to the home country. And it's going to be just equal to this world capital market, which we assume is sort of exogenous from the point of view of the small open economy. So the small open economy doesn't really influence the world capital markets. There is some interest rate on these markets, and we take it as it is and borrow and save accordingly. Right. So as we can, in the last little bit there, on the bottom of this slide 11, we see that the marginal product of capital equation, which equates the interest rate to the marginal product of capital, can be also rewritten as on the right-hand side of this, behind the or, as a condition which says that RT is f lowercase f prime of lowercase kt, right? So marginal cost equals marginal product. It's pretty standard first order condition. But a key thing that we need to stress here is that this implies if we assume R is exogenous, then this becomes one equation of one unknown. So again, I'm talking about the right-hand side here, where you can see my mouse moving. So this is one equation of one unknown. If we assume that is a small polynomial where R is exogenous, F is just some functional form. This could be just any kind of functional form which satisfies the usual conditions, and lowercase a then becomes a function of R, which is expressed here. So KT, capital per worker, in this economy is just a function of exogenous interest rate. So the first order condition automatically is going to pin down or determine the level of capital stock per worker in this economy. Okay. Right. So we can also express the net foreign assets per worker in per worker terms. So we have already defined net foreign assets 2 slides ago. We just divide them by NT plus 1, and we call the AT divided by capital NT plus 1 as the lowercase AT. And on the left-hand side, we rearrange these terms. Right. So we have this 1 plus lowercase. Sorry, 1 over lowercase 1 plus 1 plus lowercase n on the left hand side as a ratio, and that's simply because in period T L, capital L, equals capital N T, and so NT over NT plus 1 is just equal to 1 over 1 plus n. Alright, so that's the condition for net foreign asset accumulation, but in per capita terms or per worker terms. So it's the same thing as what we have here, except it's per capita. The current account is just a change defined as a change in the net foreign assets. So we know what the current net foreign assets are in period T and what net foreign assets are in period T minus 1, and the difference between them is the current account. Now I can express it dividing by NT in per capita terms or per worker terms. And well, I'm just dividing everything by NT and writing it again, and then I'm trying to sort of collect terms and make more sense of what's going on. So we can see here that we can rewrite this part as 1 plus n times lowercase at minus lowercase a t minus 1, and that's just by definition when here. So the lowercase a t is defined by as capital A t divided by n capital N t plus 1. So the number of young people in generation t plus 1. So those are the inherited, if you like, assets, net foreign assets, and consequently capital AT divided by capital NT has to be multiplied by 1 plus lowercase n when we want to express it in per capita terms. Whereas this one, the second one, is just the definition of per capita net foreign assets in period T minus 1, at the end of period T minus 1. And similarly, we can reduce these ratios on the right-hand side, the last ratio on the right-hand side, in this form, where we are just dividing everything by NT. Okay, so this equation simply tells us what's happening with the current accounts. The current account of the country, well, it depends on the savings rate, and it depends on the amount of capital stock, as well as previous year's capital stock and previous year's savings rate, and the growth rate of population. Excuse me. So to simplify the analysis, we consider a particular case of production function, Cobb-Douglas, which is constant in terms of scale, of course satisfies the usual conditions, so we don't need to worry about that. And I just plug in this functional form into our first order conditions. It's a bit of a schizophrenic world here. So lowercase a is the same thing as alpha, so you can see them as the same. There was a mistake when I went from this line to this line. Anyway, so it's the same. So where alpha is the weight of capital stock in the production function, or in a country's income. So the first order shares are first order conditions for the firm, just become explicit for this particular functional form. And so given the interest rate, I can express in the first equation, by assuming that R is exogenous, I can express K as a function of R. So what I do is divide both sides by alpha. So then I get r over alpha on the left-hand side, and k to alpha minus 1 on the right-hand side. Now alpha is between 0 and 1, so alpha minus 1 is actually a negative number. So a better way of writing it is to raise the whole equation to the power of minus 1, and that's what I get in this last line. And then rearrange, and that's what I get in this last line. So if I expressed kt in this line, I would have kt is equal to r over alpha to the power of 1 over alpha minus 1. But if which is equivalent to saying it's alpha over r to raise to the power of 1 over 1 minus alpha. Right? So I just changed the coefficient by multiplying with minus 1, which changed the order of the denominator. And at the same time, I flipped these two, so it's alpha over r, not r over alpha. Okay, so this just expresses what capital stock is equal to as a function of two parameters only: the world interest rate and the size of capital in national income, or the proportion of capital in national income. So once we know capital stock, we can solve for everything else, because as you can see here in the second first order condition, wages, which are determined domestically, are only a function of capital stock and alpha. So if I solve for capital stock as a function of interest rate at the world market, then I can immediately solve for wages as a function of capital stock, which itself is a function of interest rates. So I can just substitute, and that's what we get here. So we get wage is equal to 1 minus alpha times alpha over r raised to the power of alpha over 1 minus alpha. And I can similarly solve for consumption when young, consumption when old, and savings by substituting for wage from these equations a couple slides ago. And finally, I can solve for net foreign assets by substituting for kt plus 1 as well as for ST into the last equation, which is just the definition of net foreign assets per capita. So all of these variables are now functions of the world interest rate. All right. Let me move on and discuss the steady state. So in a steady state, world interest rate is constant, so we just simply remove the subscript t from our consideration, from our equations on the previous slide, and we get a steady state. So an assumption where the interest rate is not moving over time. Of course, since interest rate is the only variable here and no other variable exists, just coefficients, then we immediately get a closed form solution for our model. So in this case, we can express capital as alpha over r to raise to the power of 1 minus alpha. But more interestingly, there's this rt and rt plus 1. So in a steady state, these subscripts disappear, and you can simplify it even more than what it is, which is the last part here. Right? So I'm simplifying it by removing the subscript from r in both of these places. Of course, these two brackets are the same, parentheses, and so I can express it as follows. Right, so I'll just take a break because my voice is dying. Okay, so returning to where we were on slide 16, the last condition can be expressed in a steady state in the following form. So net foreign assets in the steady state can be positive or negative depending on which part of these parentheses, which of the two components of the expression in parentheses is greater. All right, so if this is greater than that, then obviously everything is going to be positive, and if it's the other way around, it's going to be negative. So we could have a country which is a net lender forever, or we could have a country which is net borrower forever from the rest of the world. The current account in the steady state is then just going to be equal to the following expression, where I assume that AT, since we are talking about steady state, is a constant. Okay, so in a steady state, literally, the current account is just equal to a fraction n, which is the growth rate of population, times the net foreign assets. So if the net foreign assets are positive, then in the steady state, the current account will also be positive. And if the net foreign assets are negative in the steady state, then the current account will also be negative in the steady state, right? This is just a typo. This is a copy by mistake, so it's the same expression on the slide 18, which I should have deleted. All right, so this brings us to a two-world economy, or two-country world. Two-country world. Two-country world is just an idea that somehow we need to be able to say something about the real interest rate. So the real interest rate currently, we assume, is exogenous from the point of view of the small open economy, but surely it's not completely exogenous. So surely it responds to something. And we are going to just say that in this we are going to express this in a very simple framework. Just develop some intuition about what determines the world real interest rate. And we'll just assume that this world consists of two big countries, let's say, I don't know, China and the US, and they determine the world market. And New Zealand or some other small open economy just sits on the sidelines and sort of takes the interest rate as given. But the interest rate is actually determined by these two big players. So that's what we're going to do. So consider countries A and B. These two countries may have different initial levels of capital stock, different parameters of their production function, as well as of their population demographics. So lowercase n A and n B are the growth rates of population. Capital income shares are alpha A, alpha B, and time preference parameters can be theta A and theta B. Each of these can be different from between the countries, as well as technologies. Capital A in country A and capital A in country B may differ. So the world capital market equilibrium or condition, since the world itself is a closed system and we are ignoring the small open economy here, so this is literally just the two countries, is equal to the demand. The worldwide demand for capital must equal to worldwide supply of capital. So the supply is on the left-hand side, so it sums up the supplies of capital stock in the two countries, and the demand is on the right-hand side, again, just sums it up. So, of course, the savings rate in both country A and country B are optimally determined savings rates. And similarly, capital stocks in country A and country B are optimally determined from firm maximization in those two countries, and so those are the capital demands, and supplies of capital are determined on this from the consumer maximization or utility maximization in each of those two countries. So we could solve for this basically. So the equation can be solved. And there's only one unknown in this equation because we're assuming that each of these, as you can see, well, you can kind of guess from going, if I went back a few slides, for one single, this is a small open economy, but nevertheless, where were we? Here, savings. Right, so savings is a function of wages, and wages themselves are functions of interest rate, capital stock per worker, which is a function of interest rate. Right, so everything ends up being a function of interest rate. So in this two-country world, I can express that capital L in each country is a function of interest rate. Lowercase s in each country is a function of interest rate, and capital K is a function of interest rate. So in the end, this equation is one equation of just one unknown, and that is the interest rate. All right, so the equation can be solved for the unknown in that equation, which is the world interest rate. And given the world interest rate, each country current account and net assets can be determined. So, of course, there will be function of the parameters of each country. So if you are a very impatient country, you will be more likely to borrow and then to save. And if you are a very patient country, you'll be more likely to save and not to borrow. Of course, if the two countries are identical, they will not trade. But since we are extremely unlikely to encounter a situation where we have two identical countries, we will likely see trade of capital stock and therefore goods between the two countries, and consequently some positive interest rate. Of course, for the world economy, the current account has to be zero. So the world economy cannot borrow or save or lend to another country, so we do not yet trade with other planets. Consequently, as a whole, the world economy must be closed. And we can imagine or discuss what will happen in this simple framework And that's what I have started with when I started doing the small open economy model in using graphical analysis. All right, so I'll return to that next, but for now, let me just conclude. In the globalized world, countries' characteristics are affected not just by the domestic monetary fiscal policy, but also by influences from the rest of the world. And in our simplest model, this was simply one influence, and that is the world interest rate. But the world interest rate is not, although it's exogenous to New Zealand and to a small open economy, is not exogenous to the rest of the world. The world interest rate is determined by these 2 or 3 or 5 or 7 big economies, which are using their own policies and so on and so forth, and the interest rate adjusts accordingly. So if there is a monetary policy action in the US, this will have an effect on the world interest rate, which will trickle down or transfer to a change in the world interest rate, which is faced by all the small open economies, and consequently will have an influence on these small open economies' current account, as well as capital stock and wages, as well as consumption and savings. So you can see there's a transmission mechanism going on in the world, which we can model in this sense, and it's an extremely simple transition mechanism right now, but you can make it much more realistic. And net foreign assets and current account are determined jointly by the economic conditions of the given country and of the rest of the world. Why the rest of the world? Again, because the rest of the world variables determine what's going on with interest rate.